it's time for another video. So in my last video we covered the section math and we went through pretty much all of what they have to offer here for booleans. Um, Something I want to add, in one of my other videos and stuff, I was looking for something that would tell me about strings and what you can add to strings. I did find it. Let me shrink this down so you can see everything else I'm looking at here. I did find it. It was this right here. I had to go to another website to find it. It has the list of things you can actually add to. There's the append one I was looking for. There's the at one, and other things you can go to for it and stuff. And I got the append one already on there. Kind of gives some ideas of how it can be used or whatnot. We don't fully understand all this stuff yet because we haven't seen it all, but we're seeing it for the first time here. String append a copy to a string. So basically take two strings and put them together using the append. In my other video I showed you how to do that. I don't know how thorough that can get into. Substring append a copy of a substring. Yeah, so here's the material on that. I found it. I haven't looked into it yet, but for the sources that I have to educate myself on C++, I've added this as a favorites spot in my favorite list for more material to go through and read through and try to understand. um, I don't know if we'll get to it in these videos. I know we're not going to get to it today because right now we are currently here. This is where I left off in the last video. So let's get started with this. So Boolean examples. We already went through a little bit on booleans, the values, the expressions, how to actually see true or false. As you can see over here, we got it set up kind of like that still from the last video. Let's see how they work in real life examples though. Let's use booleans in real life examples where we want to find out if a person is old enough to vote. We kind of mentioned that in our last video. In the example below, we use the greater than or equal to comparison operator to find out if the age 25 is greater than or equal to the voting age limit, which is set to 18. So let's clean this up a little bit here. Get rid of all this because we're going to reset most of all that. And I got an example right here, so let's go and put this example in here. Int my age is 25. In statement int voting age is 18. And then standard output insertion. And again, the quotes for the expression and stuff. My age greater than or equal to voting age. And then in. And then they got a comment here, which we'll just put down below here. Should return 1 for true. Meaning 25 years old. 25-year-olds, yeah, are allowed to vote. You got an exclamation mark in there. Okay. So here's the example. Go ahead and save that right there and stuff. Go on and run this real quick, and we get 1. Okay. Again, we learned this from last one and stuff. From the last video I just did. 1 is the same as true. But if you can't remember, if you're having trouble remembering it, go back just 1 or 2 the video or 1 or 2 of these right here and stuff and find out what it is. But you can add in standard output standard bool alpha and an end, and that way when you have that in there, the 1 will actually end up being replaced with the actual word of what it means. So go ahead and save that again, run that again, and you can see 1 represents true until you get used to what the values are for true and false. So, but in this case and stuff, we already have the set age. We already have the set voting age. This is considered a program, but what if we need to, what if we have, if you can imagine this, we are in a building, in a gym or a building, or it doesn't matter what the building is and stuff, and we have the whole uh, voting poll booths right there for people to go in to vote and everything, and we got a line of people, and we got 3 people taking these people in. And each person is coming up to us, and we're asking them how old they are, um, whether they have ID on them, they're telling us the truth or not and stuff. We could just simply get their age off of it, but what if we replace these 3 people with 3 computers that run a program? Okay, and yes, that would be taking some jobs away possibly, or possibly not and stuff. I mean, because somebody's just still gonna have to set all this stuff up and everything. But if that was a certain case, how would you set up this program to where they can enter their age? And we're not saying that they are actually sliding in a copy of their ID to get proof of age or anything like that. Maybe you have somebody else, the 3 other people, they're checking people's ID to make sure they got valid IDs or whatnot. But and then there's a computer there to verify the age when they put the age in. So if you need a program that allows people to put in an age and tells them whether they are old enough to vote or not, instead of having my age already set to 25, you would definitely probably still have the voting age set to 18, but you would be asking the person for the age. We've already gone through this on how to get this information, but let's go ahead and see how that would look. So we would get rid of that right there line, size that up a little bit. We don't have anything for this now because we just erased it, but let's move that back down. Tab. So go ahead and go down one more time. First thing we're going to need is something to ask, how old are you? So standard, I don't know why that's coming up. There we go, probably because it's something else I hit. Standard output, voting age, we don't need anything to know about the voting age, we just need to know how old the people are. So what is your current age? And you could put in what is your date of birth or whatever and stuff. We don't have a program set up to calculate what their age is based on their date of birth yet, but that's what we're just using age. What is your current age? And you can rephrase this however you want. We end that right there. We set the value, integer my age. We just got it declared. And then we're waiting for input. So there's the input right there, my age. Now we have it set up and stuff to where when a computer asks, what is your current age? It's waiting on the user, the people in line or whatnot to put in their current age. Go ahead and save that, run the program, and there it is. So that way when you put in the age 25 or 26 or whatever it is, it says true. Okay. Now we don't know exactly what is true, so you might have to make an adjustment here and stuff. Are you old enough to vote? Oops. Are you old enough to vote? As the question. And then that again. So let me open this up here so you can see all the code here. Go ahead and save this the way it is. So now we've already seen this right here, and you can input your age. Okay, we have true right here, but we don't know what true indicates. So now we are asking the question, are you old enough to vote? And that's where this is going to come in play right here. So now when we run this same program again, we put in that 25 age. Are you old enough to vote? True. Now we have a way of indicating what true is, and we have a way of getting information from a person when they're coming in to vote, for say. It can also be the same thing for a lot of different things. It doesn't have to be voting. That's just the example that they used here, and we just kind of adjusted it to where we can get multiple people's information in. So that's the first example. We downsize this again, and we'll go to the next example. And this kind of states cool, right? You can kind of do this stuff. So now we're actually getting into writing an actual program and stuff that's taking in information and giving out information at the same time. Very simple program to run, right? Not really my programs because I'm just kind of using what their examples are and just kind of editing what they have there to make this look better so we understand it more. Okay, an even better approach, since we are on a roll now, would be better to wrap the code above in an if-else statement. Okay, why are we jumping into if-else statements when we haven't covered them yet? I'm asking my source right here because I would not do this since we have not covered if-else statements yet. It is the next part though. But we're going to throw something at you and stuff, pretty much throw you into the deep pool and stuff and expect you to understand this, is what I see. But when I was at this point, I was like, what the heck is an if-else statement? Why are we doing if-else statements when if-else is the next part to cover? Why? Okay, so I'm going to end up writing code that I don't understand yet because I haven't gone through if-else statement. Anyways, let's go ahead and do it anyways, just for fun. I mean, why not, right? So we can perform different actions depending on the result. Output old enough to vote if my age is greater than or equal to 18. Otherwise, did we actually put that in the code? Yeah, I think we did. Go away. Yeah, we did. Okay, I was looking for this right here. Equal to or greater than. Otherwise, output not old enough to vote. Okay, so in this case, we're going to either get true or false, whether you're old enough to vote. Using this if-else statement stuff, it's going to do something completely different that we're not going to understand, but we're going to go ahead and write it down anyways and stuff, because like I said, it's about seeing it first. And today and stuff, a lot of people believe that you have to have a picture in order for it to be true. Well, in this case, if you write it down, you know about it. Whether you know how to use it or not, it's a different story. So we're going to keep everything the same here. Their example is still set up the same way, except for this line right here. They don't have the true or false set in there yet, but we can actually get rid of that in this example. We don't need that. The rest of this we can go and keep in here because it's still the same based off the same example. We can go and get rid of all this too because we're not going to be using this anymore right now. So we're just going to copy basically what they have in this example. If my age is greater than or equal to voting age, and we don't know what the rest of this means yet. Something about this right here, what is this doing? Output, standard output, old enough, let me put that in there right, enough to vote, period, and next one down, space, else, space, output, not old enough to vote, period, end, down, put a space right there. Okay, actually they have a comment down here we're going to go ahead and add. Output, spell right, outputs old enough to vote. Okay, so it should output this, but that's if you were sticking with the age of 25. So let's go ahead and put the age of 25 in there when it asks us, because we know we're still going to get the question asked. So we got this saved. We're going to run the program here. What is your current age? The last example had us using 25, so we're going to go and input 25, and now we're getting this result. Old enough to vote. What if it's not 18 or older? Okay, so let's change this, or let's run this again. Let's put something under 18. Let's put 15 years old. Not old enough to vote. So we're seeing this. Okay, we got one response old enough to vote. We got another response not old enough to vote, which is what we have up here. Old enough to vote, not old enough to vote. So we're kind of seeing this and stuff and seeing how something new we've never seen before works. Okay, if my age is older than voting, which makes it true, it looks like we're going to print up old enough to vote. But if my age is not greater than or equal to voting age, it looks like it's going to print up not old enough to vote. um, so let's keep moving through here because we see this now, but we just don't fully understand it yet as far as what my journey was concerned. Booleans are the basics for all C++ comparison and conditions. You will learn more about if else in next chapter. Okay, so let's move on to the next chapter now because we did our examples. This right here is challenge code, which we're not going to do. Moving on to if else. C++ conditions and if statements. You already know that C++ supports familiar comparison conditions for mathematics such as less than or equal to, greater than or equal to, not equal to. These conditions are used to perform different actions depending on whether something is true or false. C++ has the following conditional statements. Use if to specify a block of code to be executed. So we're using if to execute this block of code right here. Let me read that again. Use if to specify a block of code to be executed if a condition is true. Okay, so if this condition right here, I guess, is true in this if else statement, then we're going to execute this block of code. Else, use a specific block of code to execute if the same condition is false. Okay, so else. So if this is false, we're going to move to else, and we're going to run this block of code. Is that what that means? That's what I was kind of asking myself at the time when I was going through this. Use else if to specify a new condition to test if the condition is false. Okay, we don't have that in here, so what are we talking about? That's what I was asking myself. Use switch to specify many alternative blocks of code to be executed. What is a switch? Oh, switch is in our next category down. We got a lot to go through just for if else, so why are you mentioning switch in this? Okay. Anyways, I guess it's something we know about. We know about if, we know about else, we know about if else. We've never used much of this before. We're not even dove into it yet. We're just not getting started into if statements, according to the title here. So, the if statement. Using the if statement to specify a block of code, a block of C++ code to be executed if the condition is true. We got an example right here. Okay, let's clear out this terminal here. I'm going to go down here and put this in a comment instead. So, if condition, this condition right here, and then we got this right here. We need to put that in so it doesn't interrupt. And then we got another one right here. So this is the way it's kind of set up right here for us. I'm going to write in this right here. Block of, hold on a second. Sorry about that. I had a bit of an interruption there, so I had to pause the recording there for a second. So let's get back to what we're at here. Okay, so They have an example here that we're actually not writing into code. Instead, I am writing it into comment instead. So let me get back over here. If condition, and then I'm kind of writing the exact example into comment. Block of code to be executed if the condition is true. Okay, so in this if-else statement right here, according to this right here and what it's telling us, this is the if. If condition, I guess this is the condition. If that is true, we're going to execute this first block of code, what's in these first curly brackets right here, this part right here. That's what's going to be executed. And that's pretty much what it's getting at. Note that if is written in lowercase letters. Uppercase letters if or if will generate an error. So pay attention to that because again, this is something that was mentioned in one of the first videos when we started with these lessons here, that C++ is case sensitive. So if you type if in any way, uppercase, whether it's the I or the F, it's going to generate an error because it doesn't know what you're talking about. It doesn't know what that is. So if is always in lowercase. I'm going to say that else is probably the same way. In fact, any way these examples are printed up, if you deviate from the uppercase to the lowercase, it's going to be changed. The only way we know otherwise is when we're writing our own content right here in an output statement that's in quotes. Or if we're writing our own variable, which can be anything we want it to be. Otherwise, the keywords, this right here, all has to be specific to the case sensitivity of C++. I hope I said that right. Anyways, moving on. In the example below, we test two values to find out if 20 is greater than 18. If the condition is true, we print a message. Okay, so we are going to get rid of a lot of this code because we now have an example to run. In fact, all of this code as well. And we're going to start fresh here. The first line we have here is if 20 is greater than 18. I mean, we obviously know that 20 is greater than 18, but we're writing a program, so we need to know if this right here is greater than 20 and if it's going to work properly for us. We're seeing it for the first time, we're playing with it, we're testing it out. So if that is true, then we want it to print out 20 is greater than 18 and end. Now we don't have anything else like we did before. We just have this simple little example right here. If you need a better clarification on the example, again, you can hit the try it yourself button and see their code and see what they get as a response or whatnot. It gives the details right there. So let's go ahead and save this and run this. And it does print out 20 is greater. So obviously this is true, which we already knew that. So it's printing out this right, well, not all this, it's printing out this right here within this quote. It's just running the next block of code. It's running this code to print out this statement right here. So moving on. We can always use variables in conditions, okay? So now they're going to add to it. Let's go ahead and clear this out. Start back up here at the top because they're going to continue using this right here. So we're going to create a statement. Integer x is 20. Wrong operator. 20. Integer y is 18. Put a space there. And then in this example and stuff, they're replacing 20 with x, since that's what x is. So we're going to replace 20 with x. And the same thing with 18. 18 is up here now as we're replacing it with y. Now here's the thing. We replaced it here, or we put this here, we replaced it here. There is somewhere else where 20 and 18 are used, and that's in this statement right here. So we need to also replace 20 here with x and 18. This is kind of the easy part, but if you have, again, 1,000 lines of code, you're going to have to go through 1,000 lines to find all of this stuff. There is a simpler way to do that, but we just haven't got there yet. So for now, let's go ahead and save it, because that's the end of the example. Run it, and we are still getting x, or 20, is greater than y. We were just using the variables, and that's what this example is showing, that you can use variables in place of values, where the values were 20 and 18, where the integers were 20 and 18, and now we're using the variables instead. So it doesn't really matter at this part right here and stuff if you have x in there, but since you can see the code, you can see the x and y, or you can put in 20 and 18 and stuff, and you still know what 20 and 18 represents, that it represents x and y, so forth, so on. Moving on. Example explained. In the example above, we use two variables, x and y, to test whether x is greater than y. Because 20 is greater than 18, the condition is still true, and the message still prints x is greater than y. Using Boolean variables. Since the condition is an if statement, must be, let me read that again. Since the condition in an if statement, dyslexia, sorry about that. In an if statement must be either true or false, you can store the result in a Boolean variable instead of writing the comparison directly. Okay, so what this is saying, I'll go ahead and write this example in here first. So we're going to go down here and write a Boolean is greater, is x greater than y in that statement. And then they're going to replace the x and y right here with is greater. Okay, so that's pretty much the end of the example. So instead of having the x and y in here, okay, they're using two variables that they were comparing, and instead of doing that, we're storing the result of this right here and this variable right here. So you see how we're using two variables to start off with two values, then comparing them. Whatever the result of that comparison gets put into another variable, then that variable gets put down into here, and whatever that variable is determines whether or not this line of code gets executed. We don't really need this down here right now. So you can kind of see how we're doing, putting multiple things in multiple places and stuff to get the same single result. Question is, I mean, a question I had, or maybe some other people may have and stuff, why go through all this trouble of writing all this code to do the same thing we were doing at the very beginning? What were we doing at the very beginning? In the very beginning, we were just simply putting standard, comment this out first, standard output, um, 20 is greater than 18, end. Doesn't that seem like a lot simpler code to put in and stuff than this right here? It does. But what if we didn't know about one of these? And we've already demonstrated that once. What if we didn't know about one of these? What if we wanted the input from somebody else? We didn't have this input pre-imprinted in here. We had y, but we didn't know what y was because we were getting y from an external source. Well, okay, so we take this and replace it with y, right? And now we have that same source in there and stuff, and we determine it with the inputs. So we're getting a true or false statement here. But here's the thing. When you see me do that example before, I had to add in some stuff to make sense of what the true statement was. We would get in the outcome true, or we would get false. But we didn't know what was true and what was false. Okay, so we had to write in a question, especially when it came to voting. Are you old enough to vote? Then you put your, or what is your age? You put your age in there. Are you old enough to vote? And then we would get a true or false response out of that. That is why all this extra stuff exists. You don't know when you're going to need a Boolean response. You don't know when you're going to need an if statement. You don't know when you're going to need statements that have variables and values to them. Knowing about them, though, allows you to be able to change your code to be able to make a program that'll work for real life scenarios. Right now, we don't know what we're going to need. We don't know if, for example, how many cars there are in a line at a drive-through. So you go through and count them. Well, what if we could write a program and stuff that picks up off of sensors or something like that? There's 20 sensors, and each sensor has a car sitting underneath it. Well, in that case, you would have 20 different booleans all stated to true, and it would add them up in a mathematical equation or expression and tell you that there's 20 cars. What if there's more than that? Well, we know there's 20, so we can put in a if statement saying that it is true there is 20, but there also may be more. So it just kind of depends on what you need the program or the code to do at this point in time. So knowing about it makes it easier to write the code. Not knowing about it means that you don't know about the booleans, you don't know about the if statements because this is the newest thing you're learning right here. Knowing about it makes it to where you can change the code for what you need it to do. So that kind of right there, I mean, I didn't understand that when I first got to this journey part and stuff, but I do since I've gotten through this a lot more and stuff. I kind of understand how this code can work in different applications. Different scenarios in real life. It doesn't matter if it's something like the drive-through thing, something like the voting thing, something like a game, um, something like as simple as turning on a TV, whatnot. So there are many different ways you can use code right here to manipulate things, and we are just kind of right now we are learning about all of them. We are kind of being overwhelmed at this point and stuff because we got quite a bit more to go through still, and we've only gone through one, two, three, let's see, 10 of them. Not to mention the other sources that I have here that go deeper into diving on all these things and stuff and how you can mix and match this stuff so much more. Anyways, let's keep moving forward. This can make your code easier to read, especially when the condition is complex or used more than once. There's another example right there, used more than once. Yes, we got this right here. It might be used more than once, but this right here tells us, even after it's used more than once, or if we want multiple times, yes, the first 20 people in line were old enough to vote. You're getting stats now. Out of 50 people total, the first 20 were old enough to vote. We had one person, the 21st person was not old enough to vote. Out of all the 50 people, we had 3 total that weren't old enough to vote. The rest of them were old enough to vote. So 47 people out of all of them were old enough to vote. So now we're getting stats. What do we use stats for? We use it for football or sports in general, period. Racing, hobbies, stuff like that. I mean, you see those stats everywhere. So now we're finding something else and stuff. Well, he's got a batting average of this, or from the free throw line, he scores this many times. How many times a week do you stop and get fuel, get groceries? How much does it cost you on average to get groceries per month? So there's a lot of different ways you can do this. My mind does things where I can see multiple things using my imagination and how things can work together. And then all I have to do is just be really creative about getting it to work. But I can't be really creative if I don't have the information. I didn't know about if before this, but now I do. I didn't know about booleans and stuff until I started studying C++. Now I can start writing my own code to help me in life, myself. And if this helps somebody else, maybe I can either share it or sell or whatever, pass on the information to somebody else in some form or another. so they can use it in their life to make their life easier. I mean, what if you can save yourself an hour a day just by simply writing some code that would optimize your routine of what you need to do? So you have 5 different places to go in a single day, and each one has a deadline of when to be there, and you're running really close. Well, you build yourself a program. You can set all the addresses in there, and it'll tell you when you're going to get to each location, whether you're going to be late or not. And if you're going to be late, 5 minutes late and stuff, and you know that they're going to be closed at the 5 minute bell, why even go there? You know they're not going to be open when you get there because you're 5 minutes late. They closed right at 8 o'clock. So save yourself the time, call them up, reschedule it for another time. You're going to be 5 minutes late. You're not going to make it before they close the doors. They might make an exception, they might not. But at least you know about it prior. I mean, yes, we already have GPS and stuff. It tells you when you're going to be there, but GPS isn't 100% accurate because of traffic or whatnot. But still, that's besides the point. We know about it. Knowing about it is everything. It gives us the power to adjust our lives accordingly. Moving on. So we're done with if statements. Now we're going to go to else statements, which we have already used else statements once before and stuff. We just didn't know what it was for. So now we're going to get into this right here. The else statement. Use the else statement to specify a block of code to be executed if the condition is false. So we already dealt with this right here, simply being true. So now we're going to say, but what if it's false? What happens then? Well, according to this, use the else statement to specify a block of code to be executed if this condition right here, being false. Because we know what happens when it's true. It runs this line of code right there and prints this to the console. You know, if this is false, what are we doing? Okay, so we got an example right here, or syntax it says, but example right here. So I'm going to go ahead and write this in here to make this easy to understand. Comment if, and you've seen this before already, condition. Um, yeah, I'll go ahead and do that. Oops. Okay, and this one right here, you've already seen this. Block of code to be executed if the condition is true. And then we're going to have the else right here. So this is where else is placed with the another set of curly brackets. Can comment that out, put that there. So this is how the code will look. Tab, tab. Block of code to be executed if the condition is false. So, and like I said, we've already done this before. We did this in another example. We just didn't know what we were doing, what we were using. Now we're getting the explanation of it. So, if this condition is true, it runs this. We already know that. We've already seen that. But if it's false, according to this right here, this condition gets run. So if the condition is true, we run this line of code right here, which is this line of code in our program. But if it's false, apparently it runs to this line of code right here. The block of code gets to be executed if the condition is false. So now we have two things that we can run based on the condition right here. Yeah. So if you were looking at a coin, you got two sides to the coin, but so far we've only looked at one side of the coin. Coin like that, you've only looked at one side. Now we're going to flip it over and see the other side of the coin. What's on the other side of the coin? Sort of thing, I guess. So now we have an example, but let's see, let's read on here because we don't want to miss this right here. In this example below, the program checks the value of time. If it is less than 18, it prints good day. Otherwise, it prints good evening. All right. We can go ahead and keep this down here for now. We got an example right here. Let's go ahead and clear all this out because this code is no longer going to be helpful to us for this right here example. So we got integer time is 20. And then we got our if with our condition, time is less than 18. So if it's true, according to our commented out block of code down below, if it's true, then we're going to end up running this line of code right here. Good day. But if it's false, we need to add a little bit more. So we're going to put our else for if it is false, and put another line of code to be run if it is false. So in this case right here, we're going to run good evening. And then go ahead and save that there because that's the end of the example. Actually, it's not really the end of the example because it does have a commented part right here that says this should output good evening. Now, I'm not using capital letters, but that's fine. All right, again, save it. So we have an if statement and else statement. The if statement, the first line of code will be printed out if the condition right here is true. If it is false, it will skip this one right here and go to this one. That is a good way to think about it. It took me a little bit to get that memorized in my head. If the condition is true, the next line of code is what's going to be run. Think of it more that way. The next line of code, this one right here, will be run. If it is false, it's going to skip the next line of code because we don't always use this right here. We'll get to that later, but I want you to kind of think about it that way because I wasn't thinking about it that way at the first time around. I was thinking about it more like, okay, whatever's in these brackets right here gets run if it's true, and whatever's in these brackets get run if it's false. But not all code uses the brackets. And that's where I got thrown off later on in my education for this right here. So remember it morally this way. If this is true, the next line of code gets executed, no matter if the brackets are there or not. If it's false, it skips the next line and goes to the next line, which actually the next line is this right here, and then this. So it's actually this right here, the else. It just skips this if it's false. So we got this saved already. Let's go ahead and run it and see what happens here. And it says good evening because 20 is not less than 18. 20 being our time. So this is actually 20 right here is not less than 18. It's actually greater than 18. Okay. So since this is false, 20 is actually greater than. So you'd have to flip this sign around in order for it to be true. We're going to skip this line, run this line. And then this line is going to be printed up next. We're going to come up next. If we either flip this around or change this value to 15, save it, run it, then we're going to get good day. So this becomes true because 15 is less than 18, so then we're going to run the next line of code. We're not going to skip the next line of code, we're going to run it. It doesn't really say whether to skip the next line of code or not, but I found later on and stuff that because this uses the brackets, not all code uses the brackets. So you got to kind of keep that in mind that it's not always what's in the next set of brackets, it's what the next line of code is, which the next line of code is this one right here. So then this will run as it's the next line of code, and it'll print this right here to the terminal. Okay, moving on. So we got that example done. Example explain. Because time is 20, which we changed it, but The condition time is less than 18 is false. So the code inside the else block runs and prints good evening. If time was less than 18, the program would print goodbye instead, or good day instead. So again, it's just basically stating that since, yeah, that's fine, 51. Since 51 is not less than 18, we're skipping this line, we're running right here instead. So moving on. Using a Boolean variable. Okay, so we discussed Boolean variables and Booleans and stuff because right now we're just basically using the uh, variable versus a value that doesn't have a variable or anything like that, just straight value, an integer. You can also store the condition in a Boolean variable and use it in the if-else statement. This can make the code easier to read. So now we got the same setup here. Okay, so we're going to keep everything the same. The only difference is we're going to, let's go ahead and adjust this to what the example shows, which is 20. We're going to add bool is day is time less than 18, sorry, in that right there, and then replace this, since this is already here, it's the same thing, we're just going to go ahead and bring the variable down so we don't have to have all that information in there. Change this to is day. So we're storing the result of this into is day, putting that right there. This can be basically anything. It doesn't have to be is day, it could be X, whatever, and you can put it right there. Okay, so that's the next example shown right there. And this is just state the same thing we discussed in Booleans, that you can just take a Boolean value, store it into a variable, and then now you can use the variable instead if you want to. Tip: a name like isDay makes it easy to understand what the condition means. So that's another good example. Time is less than 18. What does 18 represent? What does time? Time we understand, but I mean time. So what is 20? What is 18? Using isDay is kind of representing something. Is it daytime or is it nighttime? Just like what this is representing. Is it daytime or is it evening time? Sort of thing. This way, when somebody else goes to read your code and stuff, it makes a little more sense to them because they're using your variables that you're making sense of the values with to understand what your code is trying to do. Determine whether it's day or evening. So keep that in mind when you have when you're working on a team and stuff and somebody else is trying to read your code. And that's the end of the Boolean variables, which is also the end of the else right there. So let's continue moving on because we got more to deal with else if. I think we'll go ahead and pick this up. This is a good spot to pick up on the next video right here. The else if statement, which we've already kind of discussed. We started with the if, then we went to the else, which got them right here and stuff. I think this is going to just end up combining the two of them together and stuff and telling you how you can do whatever. Actually, it doesn't, because first we went to else, or if, and then we went to else. So if we were doing that, it would be an if else, but this right here actually says else if, sort of thing. So anyways, we will pick up with this in our next video. Um, like I said, just knowing about this stuff is what started me on it and stuff. I knew about it, but I was so confused at the time, so confused how this can work together in code. And I just had to keep pushing myself through it. Even though I didn't understand, I had to keep pushing myself through it, getting through all this stuff, and then going into here, reading all this stuff, every single chapter. I didn't get through all of them. There's still quite a few of them I'm still working on getting through to understand. But 28 chapters. Once you get through them all, then yeah, you have pretty much the basic concept of C++. Basic concept. After that, it's just kind of playing with it and stuff and rearranging your code and trying to keep track of it and stuff and all that sort of stuff to get better at it. But there's more than just that is involved, because even on this right here, we have a lot of libraries to figure out. So we got a lot of keywords to understand, a lot of operators to understand, a lot of libraries to understand. So it gets a lot deeper. We're just covering the basics right now. You're seeing the basics for the first time. That's what I was doing. Seeing them, I didn't understand them, but I was seeing them for the first time, which helped me get through the more complicated sources. So, which like on the creator of C++, his book and stuff, the tour, I could probably understand it a lot better now than when I could when I first started this, because when I first started, I had, yeah, this was foreign concept to me. So, again, like normal, if I have made any mistakes, any questions you want to add, any comments you want to add, anything like that and stuff, feel free to go ahead and throw that in the comments there, correcting the mistakes I've made, so forth, so on. This is not about me educating people on it. This is morely about my journey through learning C++, which is not ended yet. I'm still going through. We just haven't gotten to the part where I am currently yet. I'm kind of going back through the basics right now, re-educate myself, and as you can see, watching these videos, I have learned some new stuff, even doing this stuff with the videos. So, but this stuff makes a lot more sense now than what it did when I first started on it. So. Until next time, thank you for watching, and I'll see you then. Bye.